Christopher Walters. Thank you for joining me on this live stream or for watching it later. The reason for this is I've been watching other YouTube streamers doing these live chats, and we don't really have one for testing, not one that everyone can join. So what I've done is I've set up a piece of software called StreamYard, which allows for up to 6 people to join a live chat at any one time. And what I'll be doing is I'm doing, as you can see, I'm doing some coding in C++. I'm trying to get some practice in because I've got an exam in about 4 or 5 days. And the idea is I'm going to be just creating some classes and operators to go with them. And I will be starting off with a space object and then building up planets, stars, moons, comets, galaxies, whatever you want. And just playing around more with C++, which is a language that I've never really been familiar with. But I only started learning it about 10 weeks ago. And apart from the fact that I've done some really appalling projects at uni, I've actually quite enjoyed it. And so I will just be doing a bit of coding in this. And I'm not an expert in C++ by any means, and I will be referring to things as I code. But I'll also be doing some, if I can set it up, I'll also be doing some unit tests. Anyway, let me carry on. If you want to join the chat, which I will also be doing while I'm coding, you can make a comment in the YouTube, in the YouTube chat, and then I'll send you a link, or I'll post a link in the chat. Click on that, and you'll go to the StreamYard page, which, if you accept, will allow you to join the chat. You can do this through a computer or through your mobile phone, and it would be great to hear from you. And this is for anyone. I mean, I'm not a guru. I'm not a superstar, amazing testing expert. We let anyone, and I'm not looking, I'm looking just to chat with anyone who's a tester or a dev, or just has an interest in those things. Just come on board. Thank you. I'm going to just post the basically what I described to you in the chat so that people can refer to it and read it. Maybe that's better. All right, so let me just start some coding. Just wondering what to put in my space object. I mean, I would imagine that any object in space would have presumably a position and a mass, maybe a width or a radius. Depends on the shape of it, but most celestial objects tend to be circular. At least most things say in this. I mean, there are certain things like asteroids, galaxies can have irregular shapes, but I'm going to treat them as circular for the purpose of this and maybe make amendments later. So, actually, there is a minor planet called Haumea that has a weird, really long sort of oblique rugby ball type shape. I know the Earth is slightly squashed at the poles and not a complete circle, not a a total circle, but we'll assume it's a circle. We'll assume it and the other planets are circles in this case. And what that means is I'll specify three coordinates in x. Should I actually? I'll just do that for the moment. In y. Oh, this hello world stuff, that's something generated by the application I'm using, the ID Sea Lion. I could have probably still used an array of some description, but even point. And then I'll put. Do I want them to be ints? Yeah, that's fine. I'll put. Maybe not actually. I'll put them as float. The reason is if I do any mathematics on this, say orbital distance, etc., then I would like. Actually, that's a good point. So if I want to do x plus plus, for instance, that's probably better as an int, and then storing all distances as whole numbers. Also, yeah, okay. I'll do that for the moment. Radius I'll do as a float. I mean, I could do it as a const as well. I've always been told that for C++, the standard is to, for member class, for member objects that are private, put that in. Or put an underscore beforehand. Don't want to put anything in here. Put float. I'll put mass. Hello. So I'm just testing my microphone for a second. I thought there was a problem with it. Okay, done. So I'm just checking something. I'm just going to send a message out saying that the live chat's now running. Okay, let me just do this before. So these are all private members or private variables. Obviously they can't be seen by anything outside of this class, either code that implements it or objects that inherit from it. Or actually, they can be seen by objects that inherit from it, but they have their own values in that case. These are seen by any. What's in public now would be the constructor, the destructor, because in C++ you have to include an explicit destructor. Actually, do you have to do an explicit one? I don't. Yeah, you do. I think you do, and you don't necessarily have to do a constructor. It will create a default constructor for you. But if I'm going to pass these things into it, I may as well, I really should. So I'll just say, well, in X, I'll just say X pos in Y pos in Z pos. Oh, actually, I don't have to. What am I doing? I made a mistake here. Yeah, no, I haven't. Hold on. So where was I? Let me just finish this off. Float mass. And what you can do is you can actually specify an initializer list and put the values straight in without having to implement code directly in your constructor. So I can do this, for instance. Can't remember the exact syntax. Hold on, let me just check something. remember exactly what the syntax is. Hold on, let me just check something. Actually, yeah, no, I'm doing wrong. I don't have to declare that here. I just have to do a declaration. That's what it is. So that's fine, I think. No, actually, I should. Hold on. So I can do this. I can initialize these variables directly. It's alright, I'll shorten it somehow. Probably not a good idea, but I'll do this. This means I haven't, this orange stuff means I haven't implemented it. Which is fine because I'm just doing a declaration. I'm actually doing the definition now. Hold on. Z. And I shouldn't have to do any more than this, because all I want to do is pass these variables into the private members. Oh, I don't need to put the. What am I doing with that? I'll just confuse myself there in front. I should just be able to do that. And that's my entire constructor. I was wondering what I could do with this. I mean, I could do things like, for example, return the radius. What I could do is I could do a. I've got different other constructors I need to do. I need to do a. I need to do a copy constructor. I need to do a move constructor, which means that you copy. It's essentially the same as C equals D, where D is some existing constructor, where it's some existing space object. I can also do the default constructor, which is, well, we don't pass anything in. The problem is I have no. Do I have these 0 if I want to do a? I suppose I should. I've got nothing to put into them. I've got no values that work for them if they use the empty constructor. Sorry, just give me a second. Ooh, Australia, 246 all out. So I've just got to do one thing first. I'll get back to this coding in a minute. Turn the sound off on this. Okay. I think what I'm going to do is I'm just going to set these to 0 until I can think of something better. What this will do is, this is the empty constructor, or the default constructor, if you will, and this will basically define values for this. So they'll all be 0. So it'll be 0, 0, 0, 0, 0. Oh, I don't need to do that. Hold on. So what this does, I haven't got the syntax right. Hold on, give me a sec. I need to do this. That's why. So what this does is if somebody creates a space object C equals a new space object. All right, this is creating something on the heap, not the const A. Oh, it's still incomplete. That's true. Or if I just did, I want to do it as a. I'm just wondering. Anyway, that provides default values for all of these. Otherwise, I would have had to type it out as like x underscore x equals x pos, underscore y equals y pos, etc. Let me think what else. Oh yeah, I have to do what they call a copy constructor. So so this is a reference to another, you know. Oh, that's, I know what I'm doing. That shouldn't be there. That should be there. Oh, this is a okay, this passes in a reference, i.e., you know, the memory location of this other object that I pass in. I call it another space object, so I'll call this other. Obviously, I want everything to inherit, all my base classes to inherit these. Sorry, all my subclasses to inherit all of these constructors. Let me think. Space object other, so it's X. So what to do is, I mean, I could do this actually. I could just do this. I can just call in other. It's not a pointer, isn't it? Sorry. Oh, that won't work. Yeah, okay. Other dot X. I think this would work, I think. I'll compile it and find out and do some tests. These are private. I'm passing it in here. Of course, it's implemented. There it is. Maybe this should go on the initializer list. Hold on. Actually, I'm doing this all wrong. I realize what I'm doing. Those shouldn't be there at all. They should be here. So I'm still very new. I'm still quite new to C++ and the way they do things. All right. Okay. So actually, because this is a declaration. Sorry, this is a definition. That should be like this. All I'm doing is passing in the types. I'm not actually trying to pass in the implementation at this stage. So that should go at the bottom. And that doesn't need to be there at all, I don't think. And then that can remain. And that just becomes that. Because all you're doing is passing in, is just telling what type you're passing in. So I have a bit to learn, I think. Okay. That's not specified. That's implemented already. So this becomes that becomes that, because this is where you sorry, no, this is a declaration. This is the definition. So you declare your variables here, and as a result, and this is essentially the implementation. Well, that's fine. I don't think I need this at all now. In fact, what I might just do is copy that, put that there, and just simply do this at. So I'm just reading something. I'm just checking if I'm doing this the right way. Something interesting about the language, actually. What you specify in your list of parameters, the order which these parameters are here, has to exactly match the order of your private members. Just trying to think. I think I've only ever seen that before in Java. Sorry, in C++. I've never seen other languages. All right, okay. What I'll do. See, this says it's not actually. I shall just put that back because it's saying I haven't implemented it. Oh, I haven't done this. That's why. There, it's done now. So when you define when you do the definition, i.e., the implementation of your constructor, you do it outside of the class usually, and you can actually do it in a separate. In fact, in most cases, this would be in a separate file called a header file, and this would be in a in your CPP file, and your main would be some other file. And what would happen is that you would what was I going to say? You would define this. You would link your method or construct, well, obviously constructor, but any method to your class by putting and to a namespace, of course, as well, by putting these two little dots there, or these two colons there. So if I put this there as a space object, because space object is obviously the name of the class. What I'll just do is put that there. It's not called float, it's called radius. Silly me. See, what this does, if I've done it right, is these pass these value these. This is some other variable that you want to assign to a new object. So you're essentially creating something like C equals A equals B. And so but this is actually a constructor. So in C++, this is actually the same as this. Where that passes where B, which is some other space object, or some other subclass of a space object, is passed into A. So what I'm going to do is take that out. And so in order to do that, other gets copied and your space object, and then later on you can destroy whatever other is. And you'll do that when you with the move constructor, which I'll be doing next. What's the other one called? Mass. Ooh. It says redundant. Not really. Just wondering what I've done. What I've done for my, have I done the copy constructor wrong? Oh yeah, I know what it is. I've done this. Yay! Now what's it complaining about? Oh, that's it. It's not used. Okay, fair enough. Not used. Well. Okay, so the next one is what's called the move constructor, which basically takes all the contents of one space object and puts it into the constructor of this object. So, and for that one, you use something called std move, which is a construct in the standard template library. So it'd be something like this. Oh yeah, sorry. One thing I haven't done is I haven't specified, before I do anything, more important than this, I haven't specified a destructor. Now, the reason for this is that C++ doesn't have garbage collection. So objects in their creator, there must be, and they go out of scope, they must have a destructor, or else the memory that's taken up by the object will never be released. So it would be something like this. It would be something like destroy. Is it like destroy this? Is it like delete this? I can't quite remember what it is. Well, it would be delete each of those, each of these private objects. See, one of the big problems with C++ in the past has been memory leakage, and for and if you don't want that, well, what would happen is you get some out of memory error later on, because if you create lots and lots and lots of these, and they all go to scope but they're not destroyed, then the associated memory tied up in the variables and the members that you declare inside your space object never gets freed up for anything else, and then you just run out of memory eventually. So before I do anything else, before I forget, I'll do this. Space object. I'll let's see. I mean, there's not a lot really. There's just 4. Well, I might put more things in here, or certainly in the subclasses. One thing you have to do as well is you have to declare. You have to specify for class and for subclasses. You have to specify this as virtual. I think you do virtual destructors, and that means that otherwise, if you try and if the destructor on a subclass of space object, i.e. planet, wherever I'm going to call it, it means that one of these, it'll only call the space object destructor, which means it could also be that when you destroy the subclass will be memory that gets leaked, because it calls the base class as destructor. So it's actually this. That means that you can override space object fairly easily, or the destructor for space object fairly easily, and then we'll just put the words delete in. Oh, do these just go out of scope anyway? That's a good point. Because most people delete, say, arrays. Do I have to delete everything? Just trying to think of an example. When you delete classes, I imagine that you just oh, it's just for array objects. Okay, I'll leave it empty then. So it's just for array and pointer objects. Okay. Yep. Sorry. Nothing specified here, so I'll just do this. Yep. I'll just do it as a default and get rid of that because it's no longer necessary. So if I'm not actually going to delete anything, then it just becomes a default destructor. Let me just check something. Anyway, if you're watching, make a comment in the chat. Let us know that you're. Let me know that I'm speaking to somebody out there. And if you like, click on the link that's in the chat for StreamYard. And let me just see if there's anybody in the waiting room. Anyway, that's the. Anyway, so I've let me show you what I've done. I've done the destructor. I've done 3 constructors, including copy constructor, and I'll do the move constructor, which is one where you take some object that gets passed in, it gets destroyed, everything gets put into your new object. Space object. Where's std move? Of course, I haven't put anything in yet. No, actually, what I do is because this becomes a right hand. No, I don't start there yet. I actually start up here. So it will become a space object. This is because I'd have to write this in a declaration first. Space object. I have to do that because it's a right-hand side value in this case. No, I don't actually. No, it's fine, and that's okay, I think. And also, this can't move constructors shouldn't ever throw exceptions. I'm just trying to check something. I'm not quite sure if I'm doing this right. Okay, so it's actually like this. So that, because I'm passing in, I'll be doing that as a move I'll be doing that later. So what I'll be doing is I'll be passing in a right-hand side, a RHS right-hand side value. What do they call it? An R value. Sorry, an R value, which is strictly it's a value that doesn't have a name or sort of long-standing persistent memory associated with it. So, be like the output of a function or some new sort of temporary object, that sort of thing. Let me just try to think about how I implement this again. So it would be space object. I don't know, other. I don't know if I've got this correct. I got this wrong. Then that would become, and then it'd be the same. It would be the essentially the same as what I wrote there. So it would become .std move there. No, is it? No, I do it when I actually instantiate it. Hold on. Sorry, I'm getting myself confused here. So it'd be other .xpos. Other.x. So this is the one that's the object space object I'm creating here. This is other.x. Sorry, this is the private member I've defined up here that belongs to this specific object when it gets instantiated. This is the object that's being passed in. What happens is it's called through essentially a function called std move that basically takes it from other and then destroys it essentially, which means that the only and puts it into my class. This new this new object other dot y. So I'm doing 3 dimensions. Other dot z. Let me just think. Like I said, I'm still learning. I'm anywhere but an expert from anywhere, anything. Sorry, but an expert in C++. It's very much a new language to me. It's incredibly flexible. Can't spell. Sorry. It's actually quite a likable language in many ways. The sheer power that you have. I would like to be good at this. I really would. Okay, so that's that. So what I've done is this is the initializer for x, or the score x. And y and z. And and radius and mass. So I'll just do that. And that should have implemented. That should implement this. Oh, okay, all right. Accept. All right, no, accept there. Let me just see if this compiles. It's not a lot to run, really, but yeah, it compiles. Oh, it doesn't actually create any of these, does it? So I'll write some actual unit tests later. Okay. I can do this. I don't know what I'm doing. I assume I don't do anything with this, do I? I'll just see if this compiles. All right. Actually, let me just put a breakpoint there and run it. And just debug it. Let's see what my A looks like. Looks fine. They're all 0 as I expected, so that can work. It passes into there. That works. All right, let me just try this. Now, oh, pissed off with this predicted texting thing. So what it means is that's a copy constructor. And this should be the move constructor. Or move assigner, shall I say. Let me just check this. Have I done this right? I'm just okay, so it'll be this. So D, I'm creating this new object, of space object. I mean, right now I've not made this purely a virtual, sorry, an abstract class. So it can be instantiated. I probably don't want it to be instantiated. and I have set. I'll just take virtual off for a minute because I don't actually want it destroyed. D equal. No, actually, no, hold on. No, that's fine because it's not pure virtual, so I can't put that in. See, the difference is if I did the way you turn something into an abstract class in C++ is it only matters that one of its methods is what's called a pure virtual function. Unless I'm talking out my rear end. So if I did this instead, what it means is that I wouldn't be able to instantiate this. This remains. This would become an abstract class, and it. Well, just see what happens if I run it. Actually, that's a good question. If I get some weird error, because here invalid cast or abstract class type, I've turned by putting 0 here. I've turned the entire class into an abstract class, which means that only it can't be. You can't make an object out of it. It can only be used. It can only be used as a superclass for subclasses, so it can only be used for inheritance. If I take that off, put default back in. I will probably do that eventually. I'll probably stick 0 in here eventually, especially since the virtual destructor doesn't actually do anything. Ooh. Oh, it's stupid. All right. D equals, and what you do is you do std move, which basically gets rid of B at this point. And then D becomes, basically takes the reference, the memory locations, that we used to define C, and then just puts them into D, and C becomes nothing at this point. We're essentially destroyed. Let me just put breakpoints in. So right now, C is nothing at the moment. Okay, A should be that. B is nothing because I've not actually stepped through the code yet. This is interesting. So right now, the difference between other languages and C++ is that these essentially, in the case of B, which actually hasn't, been properly initialized yet, these just point to bits of memory, and the memory can have anything in them. So that one is 65535. That's 1. That's minus 674. It's just junk at the moment. If I step over this, suddenly this assigns this constructor here assigns those values to the bits of memory that are defined by that are used to contain the values for in underscore x and underscore y and underscore z and underscore radius, mass, etc. So this one will do what's called a copy constructor. The next one will do this line here will do what's called a copy constructor, which means it'll make a copy of C will be a copy of B with its own memory and all sorts. Let me just step over. So if I look at C is now, just bring this up so people can see it, or it can be seen. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually, let me just see if there's people in the chat. Hello, Miscreant. Oh, Miscreant, hello, how are you? Sorry, I didn't notice you before. Honestly, yeah, sorry about that. I feel really bad about that. I feel really bad about that because he actually posted in the chat and I didn't see it. God, that's awful. I wonder if he's still on. Join the chat. Not the cat, the chat. If you like. Yeah, Miscreant, if you like, join the chat. If you've got, if you're still on, and I apologize if I didn't see you. I have to be a bit more wary of this. Let me just see. I've got two screens going. I was checking CPP reference to make sure I got the syntax correct, but in doing so, I didn't see the Miscreant's message. Just check something. Just somebody's like to try to send me a message while I'm on. Actually, I'm going to take 1 minute and just have a loo break. Do the wee. We'll be back. Just a few seconds. Sorts me out beforehand. Just got to check one thing with StreamYard. This is a new piece of software that I'm using to do the group chat, or to even stream it, to be honest. Just need to check one thing. Sorry about this. It's I just need to check something. It's new. It's the first time I've used this to do any sort of live stream. Sorry. It's the first time I've ever used this to do any sort of live stream. I'll have my loo break and I'll be back in a sec. Hello, right, back again. Thanks for persevering with me there. So where was I? Yeah, if there's anybody who's watching it, just let me know. Make a comment, and I'll send you a link. And if you want, you can join the chat. And that includes you, Michael, who sent me a message or sent me a comment on LinkedIn saying that it speaks a lot. So I'd much rather be coding C++ than watching the cricket. Oh well, we've lost anyway. The Ashes are going back to Australia. We're not going to get 330 odd or whatever the total is at the moment. It was all a pipe dream. It's okay because we have the Cricket World Cup, so I just have to cry into my bed at night with that. Okay, where are we? Okay, so C is the same as B. So that's your normal sort of assignment operate. Sorry, your normal assignment operator. It looks like an assignment operator, but it's actually a constructor in this language. And then if I step, oh, we've just lost our first wicket, 15 for 1. Yep, that tells you all we need to know, really. So now, so I thought now that D is this is new. The B no longer. All the contents of B are now being moved into C, but according to this, it still has it. There's some. I mean, obviously D is now the same as C, but I thought that was the point of STD move. It was that C no longer exists, and well, C is now empty, and D is, and all the references. Sorry, all the memory that was in C has now been moved to D. Or now D points everything that was in C, and C no longer points to it. Is this something I don't understand about move constructors? Have I done this wrong? I know, let's watch a video. Let me just read this up. We can all do this. Because I think I've forgotten. I think there's something I've missed. Hold on. Wait. So the move. Okay, let me just read this. So just bring up. Something I'm missing. So our value references are well, what's referred to by these two ampersands. And if you notice in my code, they are the they define the type that I pass in to my constructor. In this particular constructor, and the purpose of that is that they define temporary objects essentially, or temporary or nameless objects. So things like hello, Well, things that, I mean, this will no longer exist once this line goes. Once this goes to the next line, the mathematical expressions, those sorts of things. These are all things that would be defined as what are called R-value references. So I'm just wondering, so move semantics is a new way of moving resources around an optimal way, by avoiding unnecessary copies of temporary objects. Based on R-value references, in my opinion, build a rapid cluster on a dynamic resource, keep track of it as it moves in and out of functions. So, no, thank you. So, we have a constructor here that takes a new int. So this is essentially a pointer. This sits on the heap, and this doesn't get destructed by on its own. You have to delete it in your destructor for holder. You also define m size as well. So it creates an array of the size that you pass in, and it stores the size as well. So m data in this case is a pointer. Size mt is an actual variable. Size t is an actual variable. So we implemented the copy constructor before, which basically takes other and then takes m size out of it and creates a copy of it. And std copy just takes one load of data, one array, and then just copies it to another array. Or in this case, what it's doing is oh yeah, just so what it does is it creates a new array of the same size, and then just creates and then passes in it creates an array of both of that's the size of both arrays, both the original array and the passed-in array, and then just copies all the data from m data from other and m data into that. From other data into m data. And so he implements an assignment operator, which is equals. So what's he talk about the move semantics? Here it is. Oh, I get it. I know why. Because this is an R-value reference, right? Well, forget that. I'll delete it in a sec. That's an R-value reference, right? So that's like the function that passes it in. So D just takes whatever is passed in, and so this gets passed in here, and these still get added. So it's actually std move that I should look at. I've got my transfers all the resources. So it creates a cast takes out the reference when it's an R value. T is the object to be moved. Just change this for a sec. Just need to read up on this, sorry. The arg value is L value. Let's pass it into std, which makes it an R value. That's move assignment. So what it does is it takes all the resources of this, puts it into member, and then returns this, which is the class, the class object. Sorry, the class that this move assignment operator belongs to when it's running. Unless all standard library objects have been moved from a place in a valid but unspecified state, that is, only the functions that are preconditioned, such as the assignment operator, can be safely used on the object after it was moved from. So it's left in unspecified. Oh, yeah, okay. So it's different behavior for standard library. This is not a standard library operator. So I thought it left it empty, but I thought. You shouldn't have to, because if it goes out of scope anyway, its structure will be called. But a bunch of things won't run. For example, undefined behavior of size equals 0. Back has a precondition not empty. SD clear. Okay, clear has no preconditions. Right, so it seems that it's got no data in it. See here, string is hello. Oh yeah, so SD string is an SD is a standard template library option. So this is now empty. This is now populated here, but it still exists. I assume it must be different. I assume it's just different behavior for standard template library objects. Obviously, this is not that. This is just a class currently with like five private variables in it, and it'll get destroyed anyway when it goes out of scope. So it's just okay. So we could do this. Let's just try this for a sec. Just stop this. It doesn't have a pointer in it, does it? I don't want to do templates right now. Eventually, what will happen is I will actually create, because this has to have a parent that could be any space object, right? So it would eventually have oh, it's not that. Eventually, I'll have that in it, and then one of these will be a T, and then T will be a parent. Maybe I'll just do it as a reference. And then what will happen is that this parameter, when I actually decide how I want to do it, will have it's a template. So on compile time, it actually decides. Sorry, at runtime, it actually decides which particular class it will, or which particular object it will do. And what will happen is in C++, multiple copies of this will be created that correspond to each individual that have each individual type in it. But it would be something like this, and that would be parent, which could be in any other space object. In fact, it might even be better just to do space object parent, because it's very likely if I did this, the reason being is that I would only imagine that if I'm limiting it to, say, solar systems, that and suns, moons, planets, comets, whatever, are all inherited from space object, then I probably don't need to do static polymorphism. Actually, no. I mean, could I do it as in a parent could be something that's not necessarily a space object, like a physical object? What happens if something doesn't have a space object? You know, if it's just a planet freely floating in space, or some object freely floating, like a star. I mean, a galaxy may not necessarily be a space object. It's a collection of objects, really. A star could belong to a galaxy. I don't. I mean, a galaxy would have all of these, but I'd probably have. It's really just a collection of. It's really a collection of stars. Actually, the idea is that I eventually would do this, and this is static polymorphism. So these things get decided at compile time. It creates multiple copies of the constructor for various types. I think it does anyway. I think, and that would just be like parent. And then would be another one of these for that, but I'm not going to do that now because I haven't fully decided in my head what the class hierarchy is going to look like and what's a space object and what's not. I think. So okay, let me just move on to some other things. Let me get rid of this first because it's stupid. Oh yeah, I'm no longer in debug mode. So get rid of this. Okay, so what I'm going to do is, what time is it now? It's 11 already. Right. Okay, let me think. What's next? Comments. Mm. Okay, right. So right. So what I'll do. So I've got my constructor. What else do I want to do with it? Oh, there's got to be an assignment operator. So the thing about, I mean, I could do, say, get mass, I could do, in get mass, or like, if I want it, or I don't know, say, right, let's say I want to simulate it moving and have it moving, say, by 1 in a particular direction along the x-axis, right? Or it could be anything. Okay, I could do, say, an add to x and some value, but you wouldn't usually do that. You'd do something. You'd implement an operator. Oh, I don't know, in pos. I don't know, but that's not a really good way of doing it, to be honest. Would be int in this case because it's in the declaration. But you wouldn't. Yeah, like I said, you wouldn't do it that way. You'd implement some sort of construct. You would implement a. Oh God, what have I done? You'd implement an operator so it can do this, say, x plus equal 3, or it's a good point. Because, oh no, it wouldn't be x plus equal 3, space object. Like where the space object is O. I mean, would you do that for position, really? Its position is just 1 point. Unless you define this as a vector, all right, or a tuple. Where that's equal to x is equal to 1, 2, y is equal to 2, z is equal to 3, and then just this, I mean, you could pass that into implement that sort of operator. What happens if you only updated x? It would be this one, I presume. No, this is an actual code. I'm just trying to. This is the board for how I might choose to implement. It's just an example of how I might choose. O is, in case it's a space object. That's not right, though, is it? I mean, because I probably wouldn't do that. I would do this. I don't know. Because I want it. Also, it depends. I mean, if it was a const space object, and you want to have it const correct, which means that it's a constant. You put constant in front of it. I'd have to do 2 of them, so it would be something like in. See, that could be a reference to int, so it could be int x int, and then you have int x in const. Which means that what this means is it shows that this returns just a value. This returns a reference to that value, and this means that which means you can change it. You can't change this because it's just a number now, and this means that it shows up for if you write const. If you instantiate your space object, C equals no. Equals for instance which means they'll all have zeros. That means that would be what, and you did. Well, it wouldn't take. Hold on. If I did that, would I actually? Hold on, no. These one have parameters in. I think. Because what I would do is something like that. They'd actually be variables that would be public. So it would actually be something like. I'm thinking about this the wrong way. This subject. It would be something like X. Now that's constant. Okay. You can do like C. I don't know. Let's say you want to do that. I mean, I'm going to delete this. I'm not going to. It wouldn't compile right now. But that would make okay. So that's a constant, and that would return the X value. See, these are private, and I want to keep them private. I mean, I could just simply move these to public, and then X, Y, and Z are always going to be. But I don't. Is there a point? Actually, that's a good point. Do I really want to keep them private? If I did, I would have to change them back to X, Y, Z radius. They just become like they just become public variables. It actually might be better. I'm thinking. To do them as const public variables, because that means they get created when they get created through the constructor. They get assigned values in the constructor, and they can't be changed. But hold on, no, I can't do that, because if I want to, have them move somewhere, I need to be able to change those values. Actually, how about if I want to be able to move my space object somewhere, then I need to be able to change these values. So how about this? Okay. I'll do this instead. STD tuple. I've got to put this here as well. No, what am I doing? Silly me. So and then do tuple in. A tuple is just it's a data structure that has two. Does it always take three? I'm thinking. Is it two or three? It's certainly not like a vector. Also, I don't want these all to be ints. You know, of course I do, because I've declared x, y, z as ints. Position get. I'll just write get position. So instead of before I actually declare my my operators, I do this instead. Also, do I want to let them? Do I want to return references, or do I want to just? No, I want to do this actually, because there are because if it's const variable, I don't want them changing these, and it may not even allow me to compile anyway. And that would become const int, so I don't want it to change. Actually, I don't even need to do that, because this will just return three numbers. So they can't change what the underlying. They can't change what's actually in the class anyway. But it's const correct in that case. So what I'll do is I'll just do this. I could do this as a namespace as well. Oh, it does a const version, so I'll do that. Turn. I should just be able to do this under C++17. Initialize a list. Which would be. Is it? Yeah, I can do this. No, but set returns a reference. I don't want to do that for const. I'll do this instead. Like I said, it's still growing. It's still a new it's still a new language for me. So there's a lot. There are still things I don't quite understand. Still more revision for me to do. Okay, so why is that complaining? No, it's complaining. Yeah, I know, because I need to do this. So I want to return references now, because this can be edited. So actually, I would return it from the this pointer object. So so this is the object that this member belongs to at runtime. X is the private member, of course. Same for all of these, and this should return. It should return something that can be used as a reference. And that's what the arrow operator does. So I wonder if this compiles. I wonder if I've done something wrong here. All right, so it does compile. All right, so I was going to write some tests, but the way I would do it is I would use catch2, which means I have to, in this case, I have to set up Basel, which I might leave for the next live stream. If you don't mind. All right, so this X. All right. Let me just see how this looks. I'll just comment all this rubbish out for a minute. I only need one of these, really. But actually, forget. I'll pick this one here. Okay, so drip B equals that. So STD. I just want to know what it looks like. So I've put IO stream in, haven't I? Oh, it's already here. STD out, C out just prints things to the console. So I'll do. I should be able to do this. Or structured binding. I'm just checking out this. What the syntax is for structured binding, which is a. It means I can bind a tuple to which is obviously the return type for these into something into just 3 separate variables instead of having to do it into another tuple. Should be slightly annoying. So I should be able to do this actually. Auto, which is a bit like it does type it does type inference. Okay, so X. It means that X and Y will be declared as ints because the this returns ints. So let me just check these. So I'll do const, and then so I want them to be different. So I'll just do that as I wouldn't usually call my variables this, even in a main statement, but I'm just messing around and it's late. I'll leave them as they are. Equals b dot const, which means this is just a constant version of a space object. It's already late, so I'll do the subclasses and everything maybe tomorrow in another live stream, just so I understand, just have time to think about it. Oh, do I have to do this instead? Oh, is it const auto? No matching constructor initialization of const subject. All I'm doing is taking the content, is binding it to an array. Oh no, it's not an array, isn't it? It's a tuple. This returns a tuple, right? So a tuple of ints. I should be able to write. I wonder if they'll let me compile it. Because that's technically how it's supposed to be, unless I've really cocked up. I'm looking at CPP reference, and it looks right. No, not a bool. I hate you. No, it's X, that's why. STD end line. Just pay end strings. Carriage return. If this runs, hold on. I think it will actually, despite what this is saying. But I'm not declaring a const base object. I'm just oh, I know what it is, because I know what it is. I haven't done that, that's why. Yay! So that's that. So let me just take this and try it again. I know I haven't declared any, I haven't done any operators. I haven't got very far at all, really, in a couple of hours, but that's a start. I'll be doing more of these. So what I'll do is, that's essentially a series of references. And then that should be B. I can't call them the same thing, can I? I can't redefine it. So just do x2, y2, z2, just to get over this hump. Oh no, that's stupid naming. I'll just click xref. Z. I'm a bit inconsistent with my variable names or my method names. I mean, there are times where I alternate between camel case and this sort of underline case. See, maybe I should have done underscore get. Sorry. Lowercase get underscore lowercase position. I like to know what people think, actually, if they watch this. Maybe I'm just a bit, yeah. I've always been a bit inconsistent with variable names. It's not a good habit to get into. Maybe my language style needs a bit of work. I'm sure there are developers now who want to punch me, or who will watch this one day, if anyone ever watches these things, and will eventually send me angry emails. Well, you know, I'll probably learn something at least, so bring it on. Maybe in the chat, I'm kind of slightly obsessed about this now, considering I missed out the one person who joined, who made a chat comment. God, I'm well rubbish today. Saturday night and I'm coding C++. Do, do, do. I'm a rock star. Well, we all know that there ain't no party like a C++ party. That, yes, yes. Hold for a second while I just run around the room like an idiot. Okay, I've had my moment. Okay, I've had my moment. Okay, so that. This is something called structured binding, where you take out what they call it, a tuple. A tuple is returned from here, and it's automatically mapped to the three new variables, or to references those three new variables. You know, kind of works. Okay, what operators do I want? So there are different operators you can do in your class. So you know, you have your standard ones, like, you know, you have your what they call binary operators, which is like that, x. You know, you got x. If x is the name of your object, x, and plus as well, of course. You do that, of course, and you know. I'm trying to think how that would work for a space object. Something gets more mass. I don't know. Probably inappropriate. Should you know, add mass or something. Unless I create. There's no point doing it just to introduce. Just to say I've done an operator. There's one says comparison, so there's equals. I definitely need one of them. So I'm going to be able to check that something's the same as something else. I probably need this. The arrow operator, which is I've used it. I used it here, so it basically dereferences. It takes X from. It basically turns this into a. It dereferences this and then returns X. But you can overload it. Just trying to think what else. So I want to have some practice in overloading operators. It's actually a big part of what I'm going to be doing next week. I just didn't know what operators I can overload. It doesn't seem to do it to a planet or some sort of space object. I mean, so these are the ones you can do, right? You can do that one. So you can do sort of. They're not Boolean. They're and/or operators for sort of byte level. Sorry, is it Boolean maths? We can't say that one object is less than another object unless you do it for one of their. This is a good one actually. I might do later because that one that is actually important because what it means is if I do cout down here, this works because xref defines this operator, which is print something to text or return. No, it's not strictly that. It's return an O stream, which is stream operator, and then which means you can send that all gets sent to cout. So I do need that one, or else I won't be able to write much about. I won't be able to specify, say, a space object in here and expect it to write anything. But it's probably not strictly necessary, but it would be useful. It's not an array, so I don't see how these are going to work. That's the and comparison. That's the or comparison. Oh yeah. It's new. Would I have to overload that really to describe as a moon or a planet? So I would need. I'd need that, of course, and I need that, which is the opposite of that, really. It's not iterator. It's not a container, so I can't use that. But maybe if I did, could a planet be a container of moons? Could the space object be a container of other things? For example, moons. I don't know. Maybe it has to be in template because I wouldn't know what class. You wouldn't know what type. You'd have to declare each type for each subclass space object. The things that the type for each space object it would have in its array. Or anything for that matter. And that could be a real pain in the ass. But that's the kind of thing that you would use, say, that for. I mean, I could do it for. I could do it for something like, I don't know if this is a good idea, but I could say that I could treat it as an array or a vector strictly, and say 0 is x. I don't know. 1 equals y. It's all right. This isn't. I'm getting rid of this. It's not This is not proper C. It's not proper C++ now. This is just me. It's just a board for me and my incoherent rantings and thinking. Z, and then I don't know, 3 equals radius. Does that really make sense? I don't know. Not really good design. I mean, I get to test implementing that operator, but is it really that good? Anyway, it's 11:48, so I'm going to wrap it up for this evening. For any people who have watched this or will watch it in the future, thank you for watching it. As I get better as I do more of these and I get better in C++ or any language or any sort of testing, and while we actually get more people on and start having conversations, which is really the whole point of this, then you'll see and then it'll get more interesting. But you got to start somewhere, and I got a bit of coding out of it, and I'm sure that some people might take an interest in it. In the meantime, I'll save this, and when I flesh it out a bit more, I'll upload it to GitHub, and people can follow my work there. The idea is that eventually I might use it to create some sort of space simulator. Anyway, I think 2 hours is enough. 2 hours is enough. But thank you so much. If you did manage to click on watch it, and I hope to. And I'll be doing these quite regularly, certainly up to Thursday when my exam is. Take care. Have a good night.